Worksheet 5.7, number 5. Okay, so what is it? What are you thinking it looks like? Okay, I agree. It looks like inverse tangent, but that would need to be u squared and a squared. It also put them in reverse order, but it's addition, so the order doesn't matter. Did that solve your problem, maybe?
Maybe. I think we should keep going.
Okay. So if I'm thinking inverse tangent, because it sort of looks like it. So can you tell by looking what u is, or do I need to kind of spell it out a little bit more here? So if u squared and x to the fourth, then what's u? X squared. What's du? Here's the big question, because if du is going to work or not. 2x. Is that good or not good?
That's good.
That's really good, right? Because now the top works, and we're good. And a is 4. You need this?
Yeah, I need that. We both use that.
And then on number 8, that's also a tangent problem.
Number 8 is also a tangent problem. A squared, u squared. Or at least it looks like a tangent problem. I guess I don't really know that for sure until the du dx thing matches up. So if u squared is e to the 4x, what is u equal to? If I square root both sides, or if I raise both sides to the 1/2, that might be a better way to say it. So 4x times 1/2 would be 2x. I think this is good news now. Because what's du? What's the derivative of e to the 2x? And so I almost have that in the top. So you're right. That turned into an inverse tangent problem. And I got lazy and didn't even write a equals 9, because a is the easy one. I can handle that.
A equals 3.
I'm sorry, a equals 3. Yes. So 1/2. Arctan is the same as inverse tangent, so I try to write it both ways just to keep us all on our toes. Of u over a, so e to the 2x over 3, and tan has the extra 1 over a out front, plus c. Yes, let's do number 10. Anything else on number 8? All right, number 10. Find the area of the region. Okay, area of the region, that's sort of code word for take an integral. All right, like find the slope means take a derivative. Find the area means take an integral. So I'm going to integrate this function from 0 to 1, and that will give me the area. I don't have any idea what that graph looks like, but I know that if I integrate, it will give me the area down to y equals 0. Okay, so that looks like, what's that look like? That's inverse sine, because it's a square root, it's minus, it's an x squared. I think that's inverse sine. In fact, a squared, u squared. This one, you might not even need to do all this u stuff because it works so nicely. So, in fact, it all fits. I'm not going to rewrite it with U's and A's because it doesn't gain me a whole lot. So, inverse sine of U over A, so x over 2. Sine does not have the 1 over A out front. Do I need a plus C on this? No, but I'm not done because what do I need to do?
You need to
Plug in those limits or those bounds. So after you integrate, then top minus bottom. There's still a few people who don't integrate and then just go straight to plug in the top minus plug in the bottom. I think that would be a lot easier, but we need to integrate and then plug in the top minus plug in the bottom. So inverse sine of 1/2 minus inverse sine of 0. And since that's calculator ready, if you're really feeling not good about your unit circle stuff, that's a safe stop. I'm guessing that would be on the multiple choice part of the test, though, so you would need to know what the inverse sine of 1/2 is. Let's see, that would be pi over 6. Inverse sine of 0 is 0. So pi over 6 is probably the multiple choice answer.
Can you do number 6, please?
Yes. Anything else on number 10? Number 6. I think I gave a hint on number 6 because that would be a tricky one. The reason I gave the hint is because I see inverse sine and I know what the derivative of inverse sine is. It's basically what the rest of this problem is. So if I let U be inverse sine of x, so this is reviewing what from way back before the break. Derivative of inverse sine. Let's see, it's square root of 1 minus argument squared times the derivative of the argument, which is just 1 for this one. Oh, and then dx. So all of this is du, and inverse sine was u. So it was really ugly, and then with u substitution it turned really easy. I hope really easy. What's the integral of u du? It's the antiderivative of u du. And this is why we did warm-ups with review questions on them. No, this is the antiderivative of u to the first, maybe? Does that help? U squared over 2. And then let's put inverse sine back in for u and plus c on the end. Thank you. I didn't hit pause in time to edit out the sneeze. Oh well.
I think that's the perfect outro.
Okay, so we did quite a bit of 5.7. We did a sine problem, 2 sine problems, and 2 tangent problems.
Can we do the review?
Yes.